Hello student, good morning. Welcome to online class. Today we are going to discuss about study of crystal oscillator. Study of crystal oscillator. Aim of this experiment is to study crystal oscillator circuit. List of equipment required for this practically is DC power supply 0 to 30 volt, digital multimeter, cathode ray oscilloscope CRO, breadboard, wire cutter etc. List of electronic component with specification: transistor BC547, NPN transistor, quantity required is 1, crystal oscillator 8.44 MHz crystal, quantity required 1, resistor R1 100 kilo ohm quarter watt carbon composition fixed resistor, quantity required is 1, resistor R2 22 kilo ohm quarter watt carbon composition fixed resistor, quantity required is 1, RC 4.7 kilohertz quarter watt carbon composition fixed resistor, quantity required is 1, RE 470 ohm quarter watt carbon composition fixed resistor, quantity required is 1. Capacitor C1, C2, C3. The value of C1 is 680 PF, means 680 picofarad. Ceramic disc capacitor, quantity required is 1. Value of C2 330 picofarad. Ceramic disc capacitor, quantity required is 1. Value of C3 0.1 microfarad. Ceramic disc capacitor, quantity required is 1. Theory regarding this practical is an electronic device that generates sinusoidal oscillation of desired frequency is known as oscillator. In order to maintain constant frequency, piezoelectric crystals are used in place of LC or RC circuit. Oscillator of this type are called crystal oscillator. Quartz crystals are generally used in crystal oscillator because of their great mechanical strength. Each crystal has a natural frequency like a pendulum. A crystal is placed between two metal plates. When an AC voltage is applied across the plate, the crystal will start vibrating at the frequency of applied voltage. When the frequency of the applied voltage is made equal to the natural frequency of the crystal, resonance takes place and crystal vibration reach a maximum value. Figure shows the circuit diagram of crystal oscillator given below diagram. The circuit of transistor crystal oscillator. A tank circuit L1C1 is placed in the collector circuit and the crystal is connected in the base circuit. Feedback is obtained by coil L2, which is inductively coupled to coil L1. The crystal is connected in series with the feedback winding. The natural frequency of LC circuit is made nearly equal to the natural frequency of the crystal. Circuit operation. When the power is turned on, capacitor C1 is charged. When this capacitor discharges, it sets up oscillation. The voltage across L1 is fed to the coil L2 due to mutual inductance. This positive feedback causes the oscillator to produce oscillations. The frequency of oscillation in the circuit is controlled by the crystal Consequently, the entire circuit vibrates at the natural frequency of the crystal. As the frequency of the crystal is independent of temperature etc, therefore the circuit generates a constant frequency. Frequency of oscillation is given by F is equal to K upon T, where K is the constant and T is thickness of the crystal. Advantage of this circuit is crystal oscillator have a high order of frequency stability. The quality factor Q of the crystal is very high. The Q factor of the crystal may be as high as 10,000 compared to the about 100 of LC tank. Disadvantage: crystal oscillator are fragile, fragile and consequently can only be used in low power circuit. Crystal oscillator are fragile and consequently can only be used in low power circuit. The frequency of oscillation cannot be changed appreciably. Procedure for this experiment is: connect all the electronic component on breadboard by using wire as shown in the figure. Apply 10 volt DC voltage to the above circuit using DC regulated power supply. Measure the output voltage between collector and emitter of the transistor using digital multimeter and note it down in the observation table. Measure frequency of waveform obtained on CRO and note it down in observation table. Conclusion: in crystal oscillator, frequency of oscillator depend upon thickness of the crystal. In crystal oscillator, we get high order of frequency stability. There is assignment for you. Please note it down in a copy and show me later on. The first question is: what is oscillator? What do you mean by crystal oscillator? Why quartz crystal is used in crystal oscillator? On which factor frequency of oscillation depend in crystal oscillator? State advantage and disadvantage of crystal oscillator. How LC tank circuit works. Explain operation of crystal oscillator circuit. Okay, thank you student. Meet you in next period. Thanks.